Gada oh.
Hello everyone, my name is Mario Raphael Tampubolon from Intake 17, and today I will explain about the amputation and level anatomy of upper limb prosthetics, component of upper limb prosthetics, and final for the fabrication and alignment for upper limb prosthetics. So enjoy the video, guys.
One is the loneliest number that you'll ever do. Two can be as bad as one. It's the loneliest number since the number one. One is the loneliest number that you'll ever do.
So first we will learn about upper limb prosthetic amputation, levels and amputation, and the basic anatomy that relates to these levels. We will focus on simple explanation so you can understand the concepts quickly and clearly. Let's get started. So, to understand amputation levels, we first need to review the anatomy of the upper limb. The upper limb is divided into several key parts. First is shoulder region. The shoulder region includes the clavicle or collarbone and the scapula or shoulder blade and the head of the humerus. Together, these structures allow the arm to move in many directions: up, down, forward, backward, and in rotation. 2. Upper arm or brachium. This is the region between the shoulder and the elbow. The main bone here is the humerus. It contains important muscles like bicep and triceps, which help with bending and straightening the elbow. 3 is the forearm or antebrachium. Between the elbow and the wrist, we have two bones. The two bones are radius and ulna. These bones allow the forearm to rotate, giving us pronation and supination, turning the palm down and up. 4. Wrist and hand. The wrist contains 8 small carpal bones, while the hand contains metacarpals and phalanges, or we can say finger bones. This part of the limb is responsible for fine motor skills, grip, and precision. Understanding these regions help us relate them to prosthetic design, because different amputation levels need different types of prostheses too. Now, let's go through the major amputation levels of the upper limb, starting from the hand and moving upward to the shoulders. First is finger amputation or partial hand. This is when one or more fingers are removed or part of the hand is missing. Function can still be good depending on which fingers remain. Prosthetic options include first, we can use finger prostheses for cosmetic appearance, and partial hand prostheses that can help with grip. This level usually has the best functional outcome because most of the wrist and forearm remain intact. 2. Wrist disc articulation. A wrist disc articulations mean the entire hand is removed at the wrist joint. The forearm bones, radius and ulna remain fully intact. The advantages is long lever arm for control and excellent pronation and supination. For the challenges is harder to fit cosmetic gloved hands, limited space for wrist component in prosthetics. 3 is transradial amputation. This is one of the most common upper limb amputation levels. It occurs anywhere between the elbow and the waist. shoulder residual limbs may reduce pronation and supination ability. Prosthetic systems may use, like first, we can use body power prostheses, second is myoelectric prostheses, and last, we can use hybrid systems. These levels offers good control and good functional outcomes. 4. The elbow disarticulation. This amputation occurs through the elbow joint. The humerus remains intact, but the radius and ulna are removed. For the benefits, we can gain strong motional control and broad surface for weight bearing. For the limitation, the prosthetic elbow joint may sit lower than the natural elbow level, and cosmetic appearance may be less natural. For the fifth is transhumeral amputation. This is between the elbow and the shoulder joint. It removes part of the humerus, and for the challenge is loss of elbow flexion and extension and more complex prosthetic control. For the options included in this transhumeral is body powered elbows, myoelectric elbows, and microprocessors control elbows. This longer the residual humerus, the better the contour and comfort. 6 is shoulder disarticulation. This level removes the entire arm at the shoulder joint. The features is no humerus remaining, and the entire arm must be replaced by the prosthesis. This is one of the most challenging levels for prosthetic use because all movements must be controlled externally. Usually, we can use with myoelectric systems, myoelectric defense, and microprocessor shoulder units, and we can also use harness-based systems. And for the last is 4-quarter amputation. This is the most extensive upper limb amputation involving removal of, first is the entire arm, second is the scapula, third is part or all of the clavicle. This is usually performed due to severe trauma or tumors. Prosthetic fitting is more complex, but modern technologies offer improved function and appearance. So, let's summarize what we learned. The upper limb consists of the shoulder, upper arm and forearm, wrist and hand. Each amputation level affects different bones, muscles and movement ability. Prosthetic choices depends on first is residual limb length, second is muscle strength, third is desired function, fourth is comfort and lifestyle. So, from the partial hand to 4-quarter, each level requires different prosthetic components, ranging from simple cosmetic device to advanced microprocessor controlled systems.
A few minutes later, 1 hour later, 24 hours later.
Next, we will learn the basic components used in upper limb prosthetics. You'll understand the major parts, what they do, and how they work together to help a user perform daily activities. Upper limb prostheses are designed to replace the function and sometimes the look of a missing arm or hand. Generally, an upper limb prosthesis includes first a socket to a suspension system. There is joint components such as wrist or elbow. For a terminal device like a hook or prosthetic hand. Fifth, a control system such as body power or camber control. Each component must be selected based on the user's needs, activity level, and amputation level. The socket is the part that fits directly onto the residual limb. Its function are: first is providing comfort, second distributing pressure, third transmitting force from the body to the prosthesis. Different socket designs exist, such as transradial sockets, transhumeral sockets, Western or Northwestern styles. Some designs give better suspension, others improve range of motion. Suspension keeps the prosthesis securely attached. Common types include: first is figure 8 harness, second is figure 9 harness, and the last is self-suspending sockets. The most common for body power systems is the figure 8 harness, which uses straps across the shoulders to control the terminal device. Upper limb prostheses can be controlled in different ways. First is body power systems, uses body movements such as shoulder flexion to pull a cable connected to the terminal device. The advantage is strong grip, durable and simple. Second is passive systems, used mostly for cosmetic appearance or light tests. 3 is myoelectric systems, use muscle signs and batteries to control a hand or a hook. The terminal devices are the hands of the prosthesis. Two main components are used. First is hooks. The hooks is lightweight, strong, precise grip, and easy to control. 2 is the prosthetic hands. The prosthetic hands have better appearance, softer grip, used for social or light activities. A body-powered hook is common because it provides excellent function. The wrist connects the terminal device to the forearm. It allows us, the users, to pronation and supination, flexion and extension, quick release attachment for easy terminal device changes. Correct wrist alignment help users bring the device to their mouth, body and workspace. The elbow units used in transhumeral prosthesis. The functions is allowing elbow flexion and extension, locking in various positions, supporting the cable system for the terminal device. The elbow unit must match the user's limb length and daily needs.
2 hours later. 1 eternity later. 1 week later.
So, for the last, we'll talk about the fabrication and alignment process for upper limb prosthesis, including transradial and transhumeral sockets. We will also learn the important alignment checkpoints and the role of harnessing and cable control. First, preparing the positive mouth. The first step in fabrication is preparing the positive mouth. We draw alignment lines from anterior to posterior and medial to lateral. These lines guide the correct positioning of the wrist and elbow components. Nails are placed in the distal portion of the cast to help attach the plaster extension. Two is creating the plaster extension. A cone-shaped extension is made using EVA or plastic. This helps set the wrist position for transradial prosthesis and the elbow cup position for transhumeral prosthesis. The cone is filled with plaster to create enough material for shaping the correct angles. Three, setting the prosthetic length. There are two lengths that are measured based on the sound side. First is for the transradial. The prosthesis should be 1 until 2 cm shorter than the sound arm, help with cosmetic appearance and functional reaching. For the transhumeral, the length depends on measurement from acromion to lateral epicondyle. Subtract the length of the elbow unit to get socket length, and maintaining proper length ensures balance and functional range of motion. Fourth is polypropylene wrapping. A heated polypropylene sheet is used to form the final socket. Measurements usually include first is wrist or cup circumference plus 2 until 4 cm. The cast length is plus 15 cm and thickness is 3 until 4. The sheet is heated at 100 Celsius minutes and wrapped over the mouth. Five, for the harnessing and cable system. The egg-figured egg harness is commonly used. For the key principles are: first is chafers placed near the elbow center. Second is straps run across the shoulder, and the anterior strap across the over-empty side and posterior over the opposite shoulder. The control cable attached to the crossback area and runs down to the terminal device. The proper harnessing allows elbow flexion smoothly, terminal device control, and provide suspension of the socket. Six is wrist and elbow alignment. The correct alignment ensures functional movement. Typical wrist alignment is like 5-degree flexion and 5-degree radial deviation. This helps the user bring food to the mouth and perform midline activities. For short stumps, more flexions may be needed, but too much reduces cosmetic appearance and comfort. For the last is the alignment checkout. After assembly, we must check first for the transradial, full elbow range of motion, ability to supinate and pronation. The user can open or close the terminal device at 90-degree elbow flexion, 70% device opening near mouth and waist. Next, for the transhumeral, correct prosthetic length, full elbow flexion up to 135 degrees. Shoulder movement is abduction, rotation, and flexion. Terminal device control in all key positions. These checks ensure safety and comfort before final delivery. So, that is the fabrication and alignment process for upper limb prosthesis. By following these steps, we achieve a functional, comfortable, and well-aligned prosthesis for each user. The elbow unit must match the user's limb length and daily needs. Fontnya gedein dah. 60.
Lama banget Mario.
Apa?
Halo. Mirip ya?
1, 2, 3.
Lama
Ini lu udah mulai belum sih?
Mario. Kali ini Mario. Woi,
Hah?
Mario lama banget, pegang.
lihat sini.
So that's for today's video. I'm sorry for any mistake during my presentation. My name is Mario Raphael Tampubolon and thanks for watching. Bye.
Thank you, everyone! Thank you, Elmar! Boom!